Sorry? Oh, sorry, it's Michael. Yes, Michael. Of course, I meant Michael. So this is a talk that has been changed on short notice. So we're moving from cyber war, which we were prevented from doing due to planes, to DNS wars, which is, I think, a very pertinent subject, especially in Switzerland, because we are now moving into an era where we're moving from unofficial DNS blocking to legally mandated DNS blocking. At the same time, technology is not standing still. And basically, the tools to deploy that are already out there. And I think from a legal perspective, the UK has a bigger problem than Switzerland, perhaps, but it's still not an easy situation technologically and I think also legally and ethically. So I would like to welcome Michael without further ado. He's at Switch DNS lead, I think, is the job title. And you can explain to us what that means.
Okay, right, thank you. Welcome. First, I think you're right. DNS is a topic that is very interesting. And that's also why I choose the title from Cyber War. That was the presentation that should be here, to DNS War. Basically because it is an eye catcher. So I'm not sure if there is a DNS war, but I will look at what's going on in DNS currently with new protocols and also on the political level and see what is going on. I work for Switch as a competence lead for DNS and DNS app use. And while in the first 10 years of my job, DNS was quite boring and DNS app use was the much bigger part. In the last 2 years, a lot of things have changed and there's a lot of interest in DNS. It goes so far that even governments ask the big cloud providers what they plan with their DNS services. You mentioned the UK, and the UK is a country where the government is really concerned about Google moving his browser users to their own DNS. So why is there so much hype about DNS? I mean, we live in 2019. All the protocols we have, they are secured. We use HTTPS. We use email over secured connection. But there's one thing missing, and that is a protocol where all the other protocols are based on. It's DNS. So for 30 years now, DNS is unencrypted. Its integrity is only protected very weak, and it's starting in Switzerland now with DNSSEC. So there's really a problem with DNS if we look at security. Let me shortly explain what the DNS does and what it is used for. This is a very basic example of DNS. You have on the left side the computer with a stub resolver that sends requests to the DNS resolver, which does recursive resolution with authoritative server. So the authoritative part is not important for today. What is important is the DNS resolver. It is important because the DNS resolver, as we all know, resolves domain names to IPs. But the DNS resolver also does a lot more, at least in the last 10 years. The DNS resolver is the perfect control point for your network. Usually you have all your users in your network, all the devices using your DNS servers, and so you see what's going on in your network. We use it for about 10 years now as so-called Dns Firewalls. These are simple lists with domain names that you can monitor, or you can even block them on your recursive resolver. And if a client requests one of the domain name that is in the list, you can either just monitor it and see it, for example, if you're looking for connection to botnets, or you can block the request if you know that it's malicious. This technique is very easy, very efficient, and quite simple to deploy, because most of the DNS resolvers have it already built in. It's so popular that Switzerland even made a law for it. The law itself doesn't tell you the technique, but the gambling law that is in place since the 1st of July also has a list of domain names this list of domain names contains unlicensed casinos and online gambling sites, and all Swiss ISPs have to block the domains in this list, and they all do it with DNS Firewall. That's a technique that's beyond, except one that is Salt, because Salt has already outsourced its DNS resolvers to Google, so they don't have the possibility to do it on a DNS level, and apparently they do it with IP, which has some disadvantages if casinos are at Cloudflare or in the Google Cloud. Maybe someone is here from Salt and can no. Okay, so this is the most important thing, and that is also, I think, the reason why we have such a discussion and such a fight over the control of the recursive resolvers. But there are two more points that are also important. You can control domain names at the resolver, but you also can gain intelligence. I don't know who is familiar with passive DNS here? Okay, so passive DNS basically is a technology where you collect information from your recursive resolver, and to avoid privacy concerns, you just take data that is exchanged between the recursive resolver and the authoritative server, because there you don't have the IP of the client, and most people see this as data that is where you don't have need for data protection. But nevertheless, you can get a lot of interesting information. First of all, you can see domain names. You can see new domain names. You can see all the domain names that are used in your network. You can see the IPs, and you can also do, if you have built a passive DNS database, if you see a malicious domain name, you can look, okay, what was the IP and what other domain names were on these IP? You have timestamps, so when was a domain name for the first time used? And you also have a magnitude, that means how many requests were there for a given domain name. So that can indicate the spread of a botnet in your network, or it can help you to identify domain names that are only resolved in your network, but in no other network around the world, which would be quite suspicious. So this is something that is quite popular, and all the resolver operators gain this information. Most the ISPs do it because it's really valuable information for incident response. There's a third thing, and that is you can track the user behavior. If you look on the traffic that comes from the operating system, you can identify individual users, or at least individual IPs that map to home users. And there you can very easily monitor all the websites that are visited and also have a timeline of activity. In Europe, usually this data is protected, so ISPs will most likely not record this data, but for example, the Mozilla DOR policy allows DNS operators to record or to keep this data for 24 hours. To summarize it, DNS resolvers do DNS resolution, but they also do a lot of things that are more important nowadays. This is, you use it as control point to block and to monitor your network. ISPs do it, enterprises do it, and also some of the cloud providers do it. For example, Quad9, they block all phishing and malware URLs they know. You can gain a lot of intelligence, so IOCs from running a large cache. That is quite valuable. You can sell it or you can use it for your own incident response. And if data protection doesn't prevent, you can track the user's behavior and also sell this data. So basically, if everything is fine, if the DNS resolver providers can use the DNS for other things, why is there a change now, and why is DNS in the news? It's because of this man. I think you all have heard of him. He revealed that especially some secret services are relying on the DNS data to track users and to do mass surveillance. This is because the traffic here from the user's computer to the resolver is unencrypted. And if the resolver is in the US, they also have access to the data that is on the resolver. That caused the IETF to create a so-called DNS privacy working group that tried to get rid of unencrypted DNS traffic. And I think that's one trend. DNS traffic over UDP will be gone. It already started, and I think in 5 years, most of the unencrypted traffic will be gone. So currently, there are two technologies that are relevant. One is called DO, the other called is DOT. The first stands for DNS over HTTPS, and the other one stands for DNS over TLS. Usually, the most common used scenario is that the OS stub resolver uses DNS over TLS, and the application, basically the browsers, use DNS over HTTPS because that's a protocol they're already speaking. And what they have in common is that they're both encrypted and that snooping is not longer possible. First, what is not included with these technologies? There's one thing, and that is DNSSEC. So they just provide confidentiality. They encrypt the traffic, but they not guarantee the integrity from the response that comes from the authoritative server to the cache resolver. So DNSSEC is needed even if you have DO or DOT. From the technology, both technologies, so HTTPS, it's there, you can just use it, and also DNS over TLS. TLS is a stack that exists for 20 years, and there's not a lot of discussion about the technology, but about the application of the technology, and that is technical from one side and politically from the other side. First, we look at DOT, that's DNS over TLS. That is the less controversial technology because it has a dedicated port, that is 853, and it is used for opportunistic encryption. So if you have an Android 9 phone or Android 10 phone, you don't know it, but if you are, let's say, an Orange Salt customer, then you already use DNS over TLS. How does it work? If you have an operating system which is aware of DOT, it does a detection of TLS for DNS, so it receives the IP of a DNS resolver over DHCP. It then checks if the resolver configured over DHCP supports TLS, and if he finds out, yes, he's answering with TLS, he uses DOT to send all the requests to the resolver. That's already happening today with Android 9 or higher. This is not so controversial because basically it keeps the network layers, and it's also detectable to the network operator because it's a separate protocol. DO, that's DNS over HTTPS, is much more controversial. And the reason for that is that it is designed as a protocol that cannot be blocked. So by design, DNS over HTTPS hides within HTTPS traffic. And as HTTPS traffic is encrypted, you cannot, and then uses port 443, network operators usually cannot identify the DNS over HTTPS traffic and block it or redirect it. There are proposals on how to prevent DNS over HTTPS if the user agrees. So you can signal to user, in my network, please don't use DNS over HTTPS because it breaks certain things. It breaks, for example, protection from malware and phishing. If your network operator does it, it breaks parental control, and it also breaks split horizon. So if you're an enterprise environment where you have domain names that only resolve internally and you use DO, you can't use these servers anymore. DO also breaks, as I said, the filtering. So DO also breaks the network blocking that ISPs have to do by law in Switzerland now for the gambling law, and very soon also for child pornography. That's one fact, and if you don't use the network operator's resolver, who will have to implement the Swiss network blocks, but you use Google or Cloudflare, then the network blocking will not work. You can configure it in the browser, so while DNS over HTTPS works on the system level, the implementations we have today all and that are relevant, they're all in the browser. So it's Firefox and it's Chrome, and they all speak DNS over HTTPS if you configure it. That's Firefox, and it shows how you can configure your DNS over HTTPS server. This is an overview on privacy and on the network blocking, which shows what you have with each DNS resolver. So if you have plain DNS, you're very bad, because if you use a public wireless LAN, so all the other users can see your DNS requests. Also, everyone who has access to the IP traffic and to the resolver can see your DNS requests. The resolver operator can see your requests anyway, because he receives them and answers them. And if you are in Switzerland and have a Swiss provider, the DNS blocking works if you use your ISP's resolver over plain UDP DNS. If you do the opportunistic upgrade to DNS over TLS, the network blocking continues to work because you haven't changed the server, but all others except the DNS operator are not able to see the traffic. So this is a clear improvement regarding privacy. You can also try to configure DOT with a browser, with a resolver that you configure manually, like you can use the Google server and configure DOT, and then you reveal your DNS data not to the ISP resolver, but to the cloud resolver. And if you use, for example, Google sees your DNS requests. They are allowed to store them for 24 hours, and by law, they are forced basically to reveal them to US authorities. The same is true for DOR. If you manually configure a DOR server, Google or Cloudflare, all your queries go to Google or Cloudflare, and they can see the queries. But one thing that is the network blocking doesn't work anymore, because Google and Cloudflare are not regulated under the Swiss law, and so they don't have to block the unlicensed gambling sites. If that is not enough and you don't trust Google and Cloudflare, you can run your own server, you can run your own DOR or DOT server at home or on your network, and then use it remotely, and then nobody sees basically your DNS requests. So that's really, if you want to be sure nobody sees your DNS request, you need to run your own DNS resolver. One thing that is scary a little bit is the consolidation in the market. We have new technologies like DOR and DOT, and the first implementers were the big cloud providers. So Google was first with DOT, and DOR and DOT now basically is implemented by Google and Cloudflare. This is the market share of all resolvers. I analyzed data that is available from the Open Observatory of Network Interference. That's a project of the Tor project, and they measure network blocking, and they also measure the upstream IP, the IP of the upstream resolver. So if you look at the IP of the upstream resolver, you can see, okay, what is the AS of the upstream resolver? And then you can estimate, okay, if the IP of the upstream resolver is in the Google AS, most likely it's the Google DNS. And this is, it might be biased data, but it's data that shows that around 53% of all the DNS queries go to Google that are done with the UNI probes. and about 15% go to Cloudflare. I think Quad 9 is here with about 2%. And if you look at the same graph 10 years ago, you would have a lot of small bubbles, all the same size, some bigger, some smaller. But now I think there's one thing visible, that is that you see a consolidation and a centralization with the two big cloud providers regarding DNS resolver services. There are concerns by governments. UK government asked the browser operators, please don't make DOR default in our country. And both Firefox and Google are already making DOR default for at least some users, and they have different ways to do it. So first, Firefox just said that they are looking into making DNS over HTTPS default for users in the US, and they already started it with a small percentage of the users. That says if you are a Firefox user in the US, and you're lucky to be one of the few that is chosen, by default your browser doesn't send the requests to your ISP's resolver, but to Cloudflare's Quad 1 server. So this is basically a move away from the ISP resolver to a cloud resolver. Chrome does it differently. Chrome also makes a test, but Chrome configured a list of cloud providers, of cloud DNS providers. So it's Google, it's Cloudflare, it's OpenDNS, it's Quad 9. And if your browser detects that you're using one of these resolvers as a system resolver, it then does a protocol upgrade and doesn't send the request to the system resolver, but directly over HTTPS, but to the same server operator. So that doesn't change the server, but it changed the protocol. So basically, if you're using Chrome and you configured, let's say, Google manually in your either router or in your system, then Chrome will use DNS over HTTPS directly to Google. But it doesn't change the centralization, so it keeps the DNS resolvers you have configured. So this one is not working towards consolidation to the cloud providers, for now at least. So the question is, why are the users of the cloud DNS servers are growing? This is a statistic from Google. Google, at the end of 2018, had about 1.2 trillion DNS requests every day, and you can see basically it's continuously growing. There are two reasons for that, or let's say there is one reason for that, and that is, this is from yesterday. In Germany, Unity Media had a big network problem, and if you looked it up in the internet, what's wrong? And then they said, okay, it could be DNS. And the solution that was given, you can change your resolver to Google DNS. And regardless if it was a DNS problem or not, a lot of users will do that. And so with every network outage, you have a few users that move to the cloud providers, and maybe they come back if the route has exchanged. And the other thing is basically the same thing, especially in countries around the world where you don't have large ISPs. If they have a failure in DNS and they do not manage to get their DNS back, they just configure Google as a DNS and they keep it that way. And also Salt did it in Switzerland. And I think that's also something we will see. Running your own DNS requires a lot of experience and it's resources, and if you can avoid it, why not let Google answer the DNS requests of your users? So I don't think there is a war about the DNS resolvers, but I think DNS resolvers get more attention from the technical community. They get more attention from politicians because they want to keep their control points and they want to be able to say what what can be accessed in a country and what can't be accessed. There definitely is a trend to encrypt the DNS. I don't have any numbers, but I think we have at least 5% encrypted DNS with Google and Cloudflare providing already encrypted DNS resolution. And with that, there's also the trend to public resolvers. So these are basically two trends that are independent. I think one is the technical trend, that you have the trend that people move to encrypted DNS until the resolver. Some of the Swiss ISPs already working with it or experimenting with it. Switch, for example, we run a DO and DOT server that you can use. There's the Digitale Gesellschaft, which offers a public DNS server that you can use with DO and DOT. So there's a movement to encrypted DNS. And the other is the consolidation to the so-called public resolvers, which are not really public because they are run by private organizations. And these trends are reinforcing each other, because if you move to a public resolver, and most of these public resolvers support DNS over TLS or DNS over DO, you also improve the number of encrypted DNS requests. If you want to take something home, there are two things. First of all, to whomever you want to send your DNS request, you need to trust them, because they see all the websites you serve to. They see when you sit in front of the computer, and they see which websites do you serve, regardless of if you use DO or DOT. And the second thing is that you have a choice. As a user, you can choose your DNS provider, but also as a network operator, you can choose which resolver you want to use. Thank you.
Thank you, Michael. I think we already have the first questions there.
Yeah, is there a DNS provider you can recommend?
Choose the DNS resolver provider you have the most trust in. That's the most important thing. If you trust Google, and I mean Google, they have a privacy policy. Cloudflare, they have a privacy policy. Quad9, they have a privacy policy. You can go there and read them, and I mean, they really care about your privacy. It doesn't mean they're bad, but you need to trust them.
All right.
Danke. Hi, Michael, I have one question. When I'm using, as a European member, a DNS server, and I'm using the 88888, who is owning that data? The data of my request, is that still European? Is that still mine? Is that US?
That's a very good question, because if you use a DNS resolver with your ISP, the ISP in Switzerland is obliged to the Telekommunikationsgesetz. So there's data protection if you use the resolver of your ISP. If you use the resolver in the public cloud that is in the US, national data protection doesn't apply. And as most of you know, the US has very weak data protection if you're not a US citizen.
All right. Other questions? All right.
The DO and DOT servers that you provide by Switch, do they also block the specific traffic that is has to be blocked by our authorities?
Yes, but that is, first of all, we run a resolver for our own network that can be used by our clients. And we do DNS firewalling, so we block known phishing sites, we block command and control servers. And because we are offering network access, we also have to block the sites from the list of the ESBK. And we only run one resolver, so if you use our resolver, the unlicensed gambling sites are blocked. But then, for example, you have the Digitale Gesellschaft. Digitale Gesellschaft also runs a DO and DOT server, but they are not an internet access provider. And for that, the law doesn't apply to them, and they don't block the illegal gambling site. So even within Switzerland, you have DNS servers that don't block the unlicensed gambling site.
All right, thank you for that. Okay, there's another question there. Yeah.
So thanks, Michael, for your talk. I just have one question. So DNS over HTTPS, DNS over TLS, they are not technologies which came up last year. They have existed for some time. So why do you think Google and Firefox and everyone is implementing them now? Why are they getting interesting now and weren't interested 2 years or 3 years ago?
I mean, Google already implemented, I think, 2 or 3 years ago. If you go back to the slide where you have the blog post from the Google security team, you see when Google started implementing DNS over TLS. I think it's just got more attention. So DO is a technology that is new. DOT is a technology, I think, that is 2 or 3 years old, and Google already started implementing it when it was released. But I think there's more attention on the privacy of the users, and that's why the cloud DNS resolver providers implement these technologies.
Okay. Was that one more question? No? There? Okay. I think we'll make that the last question so we can switch stages.
Are you aware if there's any movement towards technologies like peer-to-peer technologies or Tor for decentralizing it so that he could help me look up my name and I could look up his?
There are some very experimental ones that are based on the DNS, like GNU-NS, which basically takes the zone files of available top-level domains and then use a peer-to-peer network that basically there's no one who can see all your requests. Even with the decentralized model, you have privacy issues because as the authoritative CCTLD, we see all requests for .ch domains. There are other technologies I didn't mention that's called QNAME minimization, where you just remove the first part of your DNS query you send to the top-level domain, and then the top-level domain doesn't get the information which domain name you really queried. But then there's GNU-NS, and there are also very experimental, let's say, academic protocols that try to deliver a naming resolution service that is not based on DNS.
It's interesting, but at the end of the day, I guess you still have to trust whoever is on the other side of your Tor node. So I can immediately also see attack models. I was thinking this during your whole talk. Brilliant. I think let's give a warm applause.
Thank you.
Run away.